Welcome to Astronomy Live. Webcasting tonight, Comet Linear 29P. Might also take a look at some other comets. First exposure just came in. Now, unfortunately, 29P is quite dim. And I know it's going to be located somewhere around this point of the image, but it's hard to say exactly where. As the images come in, hopefully it will reveal itself through its motion. So I believe the comet is right about here in the image. It's very faint and hard to see. I may, after this exposure comes in, I may increase the sensitivity of the image by binning it. That will unfortunately cause it to lose color information. There was a little bit of a guiding error that led to this first exposure being blurred vertically. We'll see how this next one turns out. be the comet right here, slightly fuzzy. We'll see. I'm going to wait for one more exposure, see if it moves. This is the comet. It should move this direction, I believe, into the next exposure. If it does, then we'll just keep taking pictures like this, and that way we'll have color data. But if not, then I'll go to 2x binning and increase the sensitivity of the picture, as well as decreasing the image scale. So that helps because as the comet moves, it starts depositing its photons onto new pixels. And that can mean it remains too dim to get above the noise level of the image. But if you start binning your pixels together, it takes longer for it to move from one binned pixel to the next, and you get more photons into your light buckets. Your pixel wells act like light buckets, collecting these photons over the length of the exposure. But increasing the exposure length doesn't help once the comet starts moving onto new pixels, unless you're tracking on the comet directly, which I'm not. So you can get around that by binning the image. But as I said, because of the way color CCDs work, sorry about that, some sort of wasp or bee decided to make a home of my laptop here. Because of how color CCDs work, the each pixel is filtered for a specific color. That's why these hot pixels show up as bright green, bright red, or bright blue, because each pixel is assigned one of those colors, and they form a Bayer matrix, which allows a color image to be constructed. But once you start binning those pixels together, you no longer have color information, because you have red pixels being grouped with green pixels, and so on and so forth. So you can no longer deconstruct the color information. That's one of the disadvantages of binning. You, of course, also lose image resolution, but if the comet's moving too fast to remain on an individual pixel, it doesn't really matter anyway. So the story with 209P is this comet is interesting for a couple of reasons. One, it's coming close by Earth later this month. It will also potentially give us a meteor shower from meteoroid streams it's laid down 100 years ago or more. But it's unknown exactly how strong that meteor shower might be, or whether we'll actually get one at all or not, because it depends upon the comet's activity 100 years ago. But we didn't know about this comet 100 years ago. As you can see, it's a very dim comet. Even when it reaches its closest approach to Earth, it will still be far too dim to see by naked eye. So astronomers didn't know about it 100 years ago, so we have no idea how active it was back then. And if it wasn't active at all, if it was a dormant comet, it may not have left anything for us to run into. But depending on its activity, it might have left significant meteoroid streams for us to encounter later this month, and could put on a quite nice show. So we'll see. You have to forgive me, the bugs are coming out tonight. We're definitely entering more of a summer weather pattern here in Florida, at least in terms of temperature. The insects are loving it. Ah, huh. Okay, I don't think that was... I don't think that was the comet. It's hard to say. Do one more exposure here. It might be up here, actually. I'm not sure if this is just a fuzzy star, some background galaxy, or what. Fortunately, I don't have Palomar plates to compare to at just this moment, so I'm not entirely sure what the deal is there. I don't think this will interfere with it if I pull up the previous image. Let's pull that up for reference for a second here. Okay. Hmm. I don't know, that seemed to be in about the same place in the previous image. That might not be it. It might be here. Because relative to that hot pixel, it definitely, if this is something, then it's definitely in a different position. And that is actually consistent with where I expected the comet to be based on Sky Safari Pro. So, might be it. We'll see. We'll do one more image here. See how it looks. This comet is quite tricky to observe at the moment unless you have a very large and powerful telescope. So we got 2 more minutes on this exposure, and we'll see what the story is. If that's it, that's really it's really not much to look at, but it's consistent with what it was months ago when I observed it with my previous camera. In fact, I really didn't even see it in the individual exposures. It wasn't until I stacked them all together based on the comet's orbit that I was able to truly detect it. So it would actually technically be an improvement if I was able to see it in the individual images prior to stacking. Oh dear. I think the autoguider just went... Oh, okay. Thought it went crazy for a second. Guide star, you can see that up here. As you can see, it's not terribly super bright at the moment, but it's okay. I think it's strong enough it shouldn't have too much trouble finding it. If the signal-to-noise ratio degrades, then you can run into issues because it tries to guess where the guide star is and it gets it wrong and it drives the telescope crazy. So it's better to do slightly longer guiding exposures and have a good strong signal-to-noise ratio on your guide star than to do shorter exposures closer to the edge of the noise level of the CCD and risk going the wrong way. Okay, so here comes the next image. Yeah, there it is. That is it. It is definitely that guy right there. I saw it move up and to the left, or sorry, up and to the right a little bit with this new image. So that's it. 209p. Not much to look at, is it? So you can see why we only know why we've only known about this comet for about the last 10 years or so. It's quite a faint little thing, and CCDs like this have an advantage, a significant advantage over the old film plates astronomers used to use. CCD is far more sensitive. It doesn't suffer from what they call reciprocity failure. Film does, and as a result, in order to achieve an image even this bright, you'd have to do a much longer exposure. Well, as I mentioned before, if you do longer exposures, that's not going to help when trying to detect minor planets, comets, and asteroids that are very faint, because they're moving over time, and if you don't know where they are to begin with, you can't possibly track with their orbit over time. So without knowing a priori where to follow it, you're sunk if you're using a detector that can't detect it, can't get it above the noise level of whatever it is, film, or if you're using a CCD, above the noise level of the chip prior to it moving to a new spot on the image. And what you're going to see in 3 minutes when the next picture comes in, this little faint spot is going to move up here a little bit. And so what that means is that the light of the comet is being deposited right now on these pixels up here, not these pixels down here. So if I were to double my exposure length, it wouldn't help in brightening that comet at all. It would just smear it over the image like so. Well, to achieve an image even this bright with a telescope of equivalent size using film, you might have to expose for maybe, say, an hour instead of 5 minutes. So it's only been within the last couple of decades or so that CCD technology has become affordable enough to be in mass use. And of course, that's what everyone's using now for finding these minor planets. So we're constantly discovering new objects, new comets, new asteroids as they go by Earth. But it's not like those objects weren't there before. They've been there all along. We just didn't know about them until now. And this comet's a perfect example of that, because we don't have a very long history of observation on it. We don't know how active it might have been 100 years ago. As you can see, even now, even though it's as close to the sun as we are, it's not all that active. It's a periodic comet. It doesn't go very far from the sun. And so as a result, it doesn't have the amount of volatiles that a long period comet might have as it comes into the sun, into the sun's vicinity, because a long period comet doesn't spend very long near the sun, so it generally has a lot more volatile ices for a given size nucleus than a periodic comet will. So we've only got 30 more seconds till the next image comes in, and again, you're looking for this spot right here, and it's going to move up and to the right a little bit. There it is. Now it's right about there in the image. Now, an interesting little fact about 29P. Right now is something of a special time for it because just yesterday it reached perihelion, its closest point to the Sun in this orbit. And it did so, let's see, what was the time on that? Did so at about 7:45 Universal Time, May 6th. That's about 3:45 a.m. Eastern Time yesterday morning. So it's just passing that point where it is closest to the Sun, and you can expect that the comet's activity is going to peak soon as a result of that. Perihelion distance for this comet is about 0.969 astronomical units, so just about as far from the Sun as we are. Alright, let's see. Next picture's coming in now. Comet's right here, and now it's going to be right there. Right about there. Now, because the comet is so very dim in the image, so small, I'm not sure how much useful color data I'm actually going to get out of this in terms of trying to see what color it is. Because the signal to noise ratio is not going to be great on this, I'm afraid. But I should be able to at least get a useful image of the comet itself, enough that you should be able to see it much easier once I stack these images. If you're having trouble seeing it now, it's understandable. There's not a whole lot to look at. It's just that guy right there. Now, close approach to Earth for this comet is on May 29th. And that will be at about a distance of 0.05 astronomical units. So if you want to look for the meteor shower from this comet, that will be in just over 2 weeks' time, on the evening of May 23rd to the morning of May 24th. And it could be as much as a meteor storm. We could have over 100 meteors per hour possible, depending on how active this comet was. But personally, I'm not holding my breath. I'd rather be pleasantly surprised than disappointed. But we'll see. I'll definitely be watching for it, and if you're in North America, you should too. That we're going to get the best show. North America. If you're in Canada or the U.S., you're in prime position to observe it. Comet's now here in the image. It really is just a very faint smudge. That's all there is to it. I don't think I have too much longer before this comet sets into the trees, so I don't know how much longer I'll be able to observe this particular comet, but no problem. As soon as that becomes an issue, or once I feel I have enough images, we'll move on to another comet. as soon as we're done with this comet, I'll move on to see 2012 K1 Pan-STARRS. Let's see. So in this image, the comet's right here, and the next, it's right about here. I think that's going to about do it for 209p. There's just not a whole lot to see with this one. But I'll stack these images and I'll post the results in the video description later today. Stop the image, stop the auto guiding. Okay, let's move on to Pan-STARRS. Alright, that's it for the slew. Let's turn off autosave for a minute. This is going to be Pan-STARRS. Pan-STARRS is nicely positioned right now. It's not too far past the meridian. Let's just see how it looks. Aha. I believe that's Pan-STARRS right there. As you can see, the Pan-STARRS is a much better comet. It's much more significant than dinky little 209p. And as you might expect, Pan-STARRS is a long-period comet. Alright. Before we go further, let me check the telescope's focus. It's always good to do after you've done a significant slew like that, especially when you've got a Schmidt-Cassegrain like I do, where mirror flop is an issue. So let me get the focusing a little bit tighter on this. If you hear the construction noise in the background, there's some sort of construction work going on across the street. It is kind of loud from my end. I'm also practically choking on the diesel fumes even though I'm across the street. Alright, I don't know how loud that's getting for you guys, but it's kind of annoying for me, so I'm going to mute the microphone for now. Alright, got the telescope refocused. As soon as the scope manages to work out the deck backlash and get that star centered up, I'll start the next exposure. The first one on this Comet Pan-STARRS. Sure to turn on autosave. That's something you don't want to forget to do once you're ready to image. Yeah, one of these days I'm going to have to work on adjusting the deck backlash on this thing so that I don't have to wait for it to catch up like that. It's kind of not good that I haven't done that yet. Okay, the auto guide star's kind of centered up now, so I'm going to go ahead and start the exposure. That's good. Okay, the guider just went crazy there for a minute. I'm going to restart that exposure. Oh, okay, see, notice how dim that guide star is. That's the problem. Alright. Fortunately, there are no great guide stars right now, so just have to make do. Yeah, this is less than ideal, but let me see. As long as we don't get any thin cloud cover coming to reduce the brightness any further, I think I can make this work on this one. Alright. Try this again. Part of the problem is because I had deck backlash when I was doing the auto-guider calibration. That is factoring into its calibration, and it's going to cause it to potentially overshoot in declination when it tries to make corrections. But I think that last problem had more to do with it just being too dim. If it doesn't get a salt lock on the guide star when it takes the guiding exposure, sometimes it has a tendency to make a bad guess as to where it is in the image and correct it towards that, and that will just completely ruin the exposure. So, I don't know. It's not the best, and really what I should do at this point is simply rotate the camera until I find a suitable guide star. The way professionals do this is they plan ahead of time what guide star they're going to use. They plan all that out, and eventually I will get to that point. I need to set up some software to show basically a preview bounding box of where the image field of view is going to be and where the auto guider's field of view is going to be, so that I know exactly where I'm pointing the telescope, and that I know ahead of time that a guide star will be available within the auto guider's field of view. Right now I'm just throwing darts at a wall and hoping that there is one when I get there. But in some cases I may have to rotate the camera, and again that'd be easier to do if I knew where I was rotating it to. If I knew where a guide star would be available, if I rotated the camera maybe say 30 degrees clockwise or counterclockwise or whatever. See, this guide star is just not good. It's so dim, even with 8-second guiding exposures. It's not great, and it's dancing all around. We're getting a little more wind now, and this setup is fairly sensitive to that when it's polar aligned. So I'm not sure if that's factoring in as well. And that wind, it's just bringing those diesel fumes from construction work across the street right to my face. It's wonderful. One thing I can do is I can put the camera on my wide field refractor. It's on there right now. That would make the whole thing much more forgiving of everything, guiding and wind and everything else. This comet's bright enough and it's large enough that that might actually help. It's got a pretty significant ion tail, but you really need a wide field refractor to see it. It's so large. We'll see. Well, I'm going to let this exposure finish, but then I'll probably do that. I'll probably throw it on the refractor. Putting it on that wide field refractor means it's going to put a lot more of the sky onto the autoguided chip, and you have a much better chance of finding a decent guide star available without even having to try. Because I have a feeling it's making that guide star dance all around. Right now, I think it's having trouble locking onto it. Plus, I'm having to do really long guiding exposures. It's not really good for this mount. Yeah, it's a blurry mess. It's a blurry mess. But you can definitely see the comet. It's right there. Okay. I'm going to abort that. Abort that. Stop. Okay. Well, there's the comet. You can look at that for a minute. I'm going to be swapping the camera now over to the wide field refractor. And when that's done, we'll focus that and start taking wider exposures of this comet, hopefully pick up more of the tail. Stand by. Alright, I've swapped the camera over. Now it's time to focus it. Let's see what I can do. Let's say it's off right. Yeah. Okay, we're actually in pretty good shape here. I had the focus screw set from the last time I had that camera in there, so I figured it probably wouldn't be too far off. And it's really not. Let's do one. That's fine. Yeah, look at that. It's not too far off as it is. Alright, I'm going to turn off the subframe. That's just making it too difficult. Unfortunately, this focuser does have a bit of slop in it, so it tends to push the image around when I adjust the focus a bit. Yeah, the wind is definitely picking up too. It's perfectly still when I got out here. Now, unfortunately, it's not the case. Alright. That's better. I think. That's good. Alright. Now, let us retrain the autoguider. Wind, I'm afraid, might still be an issue. We'll see. See, now we have plenty of stars to choose from for auto-guiding. Drive calibration successful. Let's see. Meh. It's good enough that this should be 90 degrees. That's good enough. Alright. On the guider. No. So train off. Okay, let's turn on autosave so we don't forget. Auto guider. Let's do 2 seconds. Could probably do 1 second guiding. Let's see. Oh yeah. There we go. If anything, might even be helpful. Let's turn on 2x2 bidding. No, it's not. It's not. Just don't want it to chase the seeing, so we'll do 2 second. That's good. Alright. It's on. Let's take this down to 0. Okay. Go for it. No, we don't want auto dark. Oh, we don't use the hook. There we go. Alright. Alright, so for those of you just joining us, we had been viewing Comet 209P, and now we've gone to Comet C2012K1 Pan-STARRS, and we're waiting on the first exposure to come in from the refractor on this comet. There's just not a good guide star available through the main telescope right now. Could hunt around for one by rotating the camera, but it's hunting in the dark, and that could take a while. So for expediency, I've simply put it on the refractor since it's easier. Plus, we're getting increased winds now, and it's not good. The main telescope is very sensitive to that. It causes it to become a quite blurry view. So I'm hoping that with a refractor and a smaller angular resolution, or sorry, less angular resolution, it'll be more forgiving of light winds. Plus, it's not hard to find a guide star with this refractor. And it's not too bad for the comet either, because Comet Pan-STARRS, unlike 209P, is quite well developed. It's got an easily noticeable dust tail, and it also has an ion tail. But you really need a wide field of view to pick up the ion tail. It's quite a large and dim feature. So we'll see. I might have to recenter the view on the comet a bit after this first exposure. Let's see what it looks like and which way the tail is going. Okay, so you can see the comet quite easily right there. Dust tail going that way. Yeah, kind of thinking I should center up on the comet a little bit better here. Stop. Let's turn off autosave for a minute. Let's just do 2 seconds, 3x3 binning, auto dark. Rolling. Okay, that's good. Obviously, the refractor is not exactly perfectly co-aligned with the main telescope, but it's good enough. At least whatever you're looking at in the main telescope will be somewhere in the field of view of the refractor, and that's good enough for me. But you can always recenter, like I just did. Alright, our guide star's here. At the risk of letting it chase the scene, I'll do 1 second guiding corrections. No auto dark. That one. 5 minutes. Turn on save. Go. Alright. Now we start a new series of exposures. And the comet will appear right in the center of the field of view when it's done. You know what? Ah, no, no. Sometimes when you abort the image in the middle of taking an image, it will lose the guide star. Okay. Just because I can. Let's do 10 minutes. I know, it's a longer wait, but you get more light that way. Well, that's a bugger. The wind caused the auto-guiding to screw up pretty badly there at the end. It'll probably ruin that exposure. The wind picked up and blurred the star, and the auto-guider decided to go a little haywire there. Or maybe it was just the wind pushing the telescope, but whatever the case, it's making it dance. Well, let's see what we got. Well, it's not too bad. There is the comet. I think instead of 10-minute exposures, though, it might help to simply do 5-minute exposures. Just in case the wind decides to go a little crazy again. Get a better chance of at least getting one good exposure before the wind kicks in. And actually, I'm really not entirely happy with the focus. I think I can get it better. Let's see. Alright, I think we're in business now. 5-minute exposures. Hopefully the focus will be a little bit sharper. This is just an achromat refractor. I'm on a budget. I might upgrade that eventually, but it will have chromatic aberration as a result. You can actually see the comet in the brief exposures I used for focusing. It's right there. You can't see all of the tail, of course, but the nucleus is visible. That's good. There you go, there's the comet. Alright, here comes the next exposure. And there you go. See that comet moving. Alright, folks. Well, I think that will do it for the webcast tonight. Thanks for coming and watching. And I'll post stacked images of these two comets in the video description later. Have a nice night.